Okay, good morning to all of those team members throughout the on the West Coast, and good afternoon to those that are on the East Coast. We'll be starting in just 1 minute. We'll give people a little bit more time to join the call. Okay, let's go ahead and get started. Welcome to the LumenData and Databricks joint webinar on demystifying generative AI and data science. My name is Andrew Crider. I'm a director of analytics here at LumenData. We also have Bryan Schaefer, who is a manufacturing data leader at Databricks. Today, we're going to talk a little bit about when you should be using generative AI and when you should be using data science in your projects moving forward. So let's talk a little bit about what we are going to talk about today. Today, I'm going to talk a little bit about when to use large language models or data science. And then Bryan's going to talk a little bit about how Databricks helps apply these applications inside of their system. We're going to do a quick Databricks demo showing use cases of both data science and generative AI. And then we'll open up the floor for any questions or comments that might be available from the audience. If you have questions that you don't want to wait until the end, there should be a Q&A section that you can access through the Zoom interface. And you can go and put your questions there, and we'll get as many as we can at the end. So let's go ahead and get started. When to use large language models or data science? AI is very encompassing. And if we were talking about 3 or 4 years before OpenAI and Google Gemini and Meta's Llama, we would be talking primarily about what we've classically called data science. This is using neural networks and statistics to come up with predictive items for the computer to surface to us. But now that we're talking more about generative AI in the market, we really talk about 3 different use cases, right? So the first one is semantic search and proposal augmentation. Very often, this is referred to as RAG implementation, but essentially what we do is we take all of your knowledge and we embed it or create vectors for a generative AI model to surface to the user through a chatbot or through text files of information that is gathered and summarized from your current knowledge store, right? This is trained on previous work. It can be audio, multimodal, images, or text. And the primary business use case for this is to reduce the cost of research. We'll talk about that in just a minute. The second one is more call center support. This involves a number of different things, including building, say, recommendation engines for advice to customer service reps on how to talk to their customers, grouping their customers into more immediate groups that might need specific information. And this is more of a data science implementation augmented with the RAG that we discussed in the semantic search implementation. And then finally, the one with the demo that we're going to show you today is customer 360 grouping. This is taking all the information that we have about a customer, their psychographic information like age, gender, number of kids in the household, salary, things like that, and coupling that with information that we've received them in a non-structured way. So think emails, customer service chats, things like that, that will allow us to build a more complete profile of our customers so that we can service them better, right? Again, this is trained on previous work, external data sources, whether they be structured or non-structured, and then it's refined as it goes along by our customer service reps. The reason that we want to make the distinction between the two is because there are a lot of different systems out there, right? There are a lot of tools within the AI data science toolkit. And so along the left-hand side of this table, you can see that there's a number of use cases where data science and generative AI can provide real value to the business, whether it's forecasting, whether it's content generation, whether it's chatbots. And along the top, we see a number of different AI techniques. So generative models, for example, have a very high content generation and chatbot capability, but have a very low method of utilization when talking about optimization, simulations, or applying rules. For example, and then when we're looking at, for example, creating something that is non-generative, so more data science, we can see that it's very high when we're talking about segmentation or recommendation engines or intelligent automation, but it has a very low value determining content generation. So, for example, one common use case that we talk to our customers about is research. It's compiling research from the vast quantity of knowledge that we've created over time, whether this be Teams message, items in our SharePoint, Google Drive documents, anything like that. A report by IDC highlighted that the knowledge worker spends about 2.5 hours per day, or roughly 30% of their workday, just searching for information through all of the environments that they have, right? Whether they're doing article categorization, whether they're generating new content, whether they're doing research for a client's behalf, all of these are really critical when we talk about where we can find the best use of generative AI, which is summarization. And so when we talk about a little bit of what we want to talk about and what we're going to talk about a little bit later with Bryan, is that these are the use cases where these particular AI tools make a lot of sense in application, right? So if you want to do generative models, then content generation, chatbots, and knowledge discovery, right? But if your use case is something around segmentation, you probably want to use a non-generative form of machine learning, data science, if you will. And if you want to do something like optimization and simulation, like forecasting or planning or doing automated decision intelligence, you probably want to use a technique more along the lines of optimization and then simulation. Right. And so for each one of our business use cases, we want to choose the right tool. Not everything is a chatbot. Not everything is using ChatGPT. Sometimes all you really need is a good neural network to kind of build something out and feed the data correctly into it. So when we talk about these two different tool sets, data science versus generative AI, the first thing that we have to know from a technical standpoint is what the skills are needed and what are the components to actually implement it correctly, right? So for data science, we need Python and we need some statistical skills to understand when to use a linear regression versus using clustering. And for those components, Databricks has some really great resources to help us do this. They provide a Delta Lake where we can store our unstructured data. They provide serverless SQL to surface our tabular data or data formats. And then we can also use Databricks notebooks to use both Python as well as straight SQL to build out the queries that we need to prepare and train our models. Now, on the other hand, we may want to be talking about large language models, doing some very basic RAG analysis or building even a chatbot. And for that, we also need Python. It's a great tool to use for all of these. But we also need to have the more important information, which is business domain knowledge. How is the actual data going to be surfaced and used? This is where prompt engineering becomes very important so that it allows us to properly build the prompts to surface the information in a format that our users can use. And then we also need to be able to use embeddings and application design because we want to make sure that when we surface the information, we do it as effectively as possible. And often that involves building in modules or screens into our web-based SaaS applications so that our users don't have to think. They don't have to go somewhere else to find the information. It's currently surfaced within their workflow. And for this, we need structured and unstructured data. Databricks notebooks to do the munging and the embedding and the vectorizing so that we can make our models more efficient. And then we also need some form of high-speed vector database, which we can also implement with inside of Databricks. So when we look at an overall structural overview of what our data science or our generative AI ecosystem is going to look like, there's three real big things, right? So the first side, on the left-hand side, is on-premise or SaaS data. Wherever your data sits, we want to find it and make sure that it's clean and ready to use, because garbage in, garbage out is a very critical consideration when talking about large language models, as well as data science. The better the data that you put in, the better the results are going to be. And after you move that into a cloud data lake like Databricks, what we want to do is we want to migrate that data into those environments, clean it, apply business rules, and then present it to the users, whether we present it to the users as structured data for their report, like Tableau or Power BI, or whether we surf it to our data science and AI models. And so whether that's structured data, unstructured data, the Delta Lake is a great place for that within Databricks itself. And so then the part that most people don't talk about as we're going through this process is how much work actually goes into properly preparing this data. So as we move from the raw data, which is kind of our prep work, ingesting the data, vectorizing the data, to the training and building, further data cleaning, external augmentation, whether it be through user feedback or through new data sources, and then iterating and implementation of that model into where our user can receive the output or provide input, whether they need to utilize it within a SaaS application or whether they just simply need to perform some analysis. Those are the three major components. But what's not clearly, what our customers discover is that 55% of that data happens before we even train our first model. And that's where the data engineering really comes in. And making sure the data is clean, performing master data management and data quality checks on the data before it's used to train the model. Now, then the training does take some time. There's some iterative approaches to it. It's about 35% of our total usage of time and resources to do that. And the last part, whether it is building prompt engineering for our generative AI, whether it's analyzing the outputs from our data science models, anything like that is really the smallest percentage of time from a manpower and a resource allocation, right? So this is a really important thing. We can talk about all the different use cases, but what it really comes down to is what LumenData and Databricks really brings to the table, which is experience and the tools to make sure that your data is clean and ready for your data science and AI use cases. Now with that, I'm going to turn it over to Bryan so that he can go ahead and talk about how Databricks actually does this sort of application. And then I'll come back on and we'll do a quick demo of the two different use cases that we talked about earlier. Bryan.
Awesome. Thanks, Andrew, and good afternoon. Good morning, everybody. So as we talk about generative AI or just data science use cases, I'd like to talk about how Databricks is the platform, has compiled the platform, right, to make it easy for everybody involved in that gold, silver, bronze transition of data that we just talked about. But first, I want to talk about, what are we talking about when we're talking generative AI? Chatbots are the first thing that folks talk about. But as Andrew said, right, there's a lot more potential use cases, and there's some use cases where maybe LLMs and generative AI doesn't make a lot of sense. So when you think about generative AI, think about the types of use cases that have to do with things like questions and answers, content or code generation, personalization, right, based on maybe somebody's behavioral or existing user experience, in translation services, being able to take content and globalize it, like you see on the screen here, as well as things like storytelling or creative writing, or somehow creating content that's beyond just simple prescriptive guidance on or forecasts, right? So we're seeing generative AI use cases here at Databricks across customers in multiple sections. I'm here to represent manufacturing today, or that's where my expertise is, but certainly I have some exposure to some of these other verticals as well. And the reality is that customers that are leveraging generative AI today are distinguishing themselves against their competitors. From things like generating in the utility space, things like rate quote generations, content, or doing other automating research, collecting of data across different data sources, across different open data format, open data that's out there, as well as personalizing it with the thing that really makes your business unique, which is your business's own data. And how Databricks has been built, essentially, we'll jump into why the Databricks platform is the best platform of choice, and the considerations that we've taken to putting out a user interface and a product that is really democratizes data. So essentially, everybody from data engineering to data scientists and business intelligence users can leverage the Databricks platform, because what we've done is given a user experience that allows you to incorporate pretty much any common language that you might use today, mostly Python, SQL, but there's certainly R, Scala, etc. in one notebook. Being able to bring visualizations right into where you're doing your work, as Andrew will show later. Being able to track, ML experiments, LLM results, model building, training, etc. We'll get into that in a little bit. And being able to make sure that things are collaborative, right? You can have multiple teams that want to ask similar questions, or maybe benefit from questions that other teams are asking against data. And then essentially, right, an enterprise-ready platform that can scale to the massive amounts of data that are out there and coming at us every day. So bear with me 1 second. This should not be a build slide. It's interesting. All right, there we go. So apologize for that. So essentially consider, being able to take all of your, all of your plug and play technologies that are out there, right? Whatever your favorite is, and combine them into one environment. Use the ML libraries that are popular, that you want to use, that you're comfortable with. Compare, contrast different libraries together, and essentially add customization, but do it in a way that enables you to maybe do it on one small cluster to consolidate on costs, or small compute just for local testing, or larger compute for maybe shared clusters with other users. Being able to test and scale based on real-time input of data and your needs, but also allowing you to control things like costs and expense that are associated with building out some of these things, so that you maintain a strong R. So, and then, the other idea of being able to test and get insights into how your ML is performing, right? Whether that's, building out and augmenting LLMs, whether they be open source or proprietary licensed models that you're using as a foundation. The idea is, again, tying in your personal data, your customer or your corporate data that makes you unique with those foundational and open models to be able to do things further downstream. But the idea is you want to be able to with just one line of code, be able to identify, logs, parameters, metrics, data, lineage, et cetera, so that you can compare, contrast, and see the work that you're doing. Um, you know, how does, you can ask questions about like how does tuning a parameter affect my model, my metric? Which maybe is the best model to use, or maybe we should use multiple models in order to maybe have some voting. And did I train long enough? Should I, is the model fine-tuned, or is the customization that I've done enough to give me the result that I need? And ultimately, where what we'd like to encourage is leveraging what we talked about, right? Leveraging the platform to really put some thought into an iterative approach to building out generative AI. Most of our customers start with prompt engineering. Essentially, what are the right questions to ask? How should I ask it in a way that the model is going to give me a result that meets my expectations? Through RAG, or retrieval augmented generation, right? Take my real-time inference data or something like that, and apply it against an LLM to augment the result that we want to get back. And this is common for things like customer 360, right? Understanding what a user may have experienced right up until they called in for help or something like that. Right? Or understanding their behaviors, things like that. Fine tuning, essentially, right? Taking a pre-trained model, adding some of your domain knowledge and custom data, or pre-training, basically building a model from scratch. That takes a lot of things, billions, if not trillions, or even beyond lines of data. A lot of customers don't always have that, but this is where maybe LLMs aren't the right approach, but what we're calling MLMs, right? Medium language models, or even small language models, to be able to offer up very specific use cases. Ultimately, the more customization you do, the more controls you have in place. Ultimately, compute and complexity are also growing with that. So it's important to consider the right level of customization for the use case.
Okay, Bryan, thank you so much. With that, let's actually see all of this in action. Today, we're going to talk a little bit about a customer 360 demo for an online retailer who wants to gain more information about their customers and use that information to provide better recommendations to them, as well as targeted advertising. So like any customer 360 SaaS demo, right, we're going to start with CRM. This is what we sold, who we sold it to, how much we sold it for, as well as information about our customers, including psychographic information, as well as demographic data. So we're talking things like how many kids they have at home, what their salary looks like, whether they have a graduate or a bachelor's degree. All of this information to drive our understanding of our customers, group those customers into meaningful groups, and then target each one of those customers groups effectively with data science and large language models. Now, LumenData has a long relationship with Informatica as well as with Databricks. And so with Informatica, we cleaned this data. We got all of our data mastered into a normal format. We took it from the various different data sources, moved it into Databricks. And with that, we'll use large language models and data science say, for example, to generate an email or generate custom Instagram stories, and then funnel that information back into our e-commerce system, so that we can make sure that we're tracking whether we were successful with our A/B testing of our emails back into Databricks, which further refines our model, which makes our large language model and data science predictions better and starts this chain over again. Kind of this iterative approach. And so what we'll do is we'll go to the slide that says demo, and you'll glance at it while I switch which screen I am sharing. And we'll come here. And we'll start off with what is a fairly typical analytics outlook of all of our data, right? So we have 3,000 customers who've generated about 3.14 million revenue. Here's our median age, how many countries they come from, and look, there's over time whether our revenue is, what countries they come from, total revenue over by date, and kind of our demographic information on what their education level is or what their marital state is. Now you'll notice here that we've clustered these groups of customers into two groups. The reason that we did that was that we've identified, primarily by revenue, what each customer group are looking for. And so at that point, you kind of have a choice. Do I target the cluster that has not provided a lot of revenue or a lot of sales or a lot of volume and try to increase that number? Or do I target and reinforce the message to my most profitable group so that I can increase the revenue that they generate? The first thing that we need to do, however, is perform a little bit of data science. And so for this, what we're going to do is that we're going to import the data set that has a number of different demographic informations. We're going to combine them in a number of different ways and find where our clusters sit. This is the grouping based off of their psychographic and tabular data information that tells us that we're driving for the right revenue, which in this case is revenue, and then group those customers so that we can then identify who we need to talk to or in whatever A/B testing we want to do. After we're going to cluster them, we're going to create we're going to do a little bit of analysis on what it is. We're going to make some discoveries, and then we're going to go to the next step, which is how our recommendation engine uses this information to drive further sales. So we're using Databricks Delta Lake here and Python. And as you can see right here, this is what our data looks like. So for each customer, we have their revenue, how many items they've bought, what their average purchase amount is, and then a number of demographic and psychographic information, right? What their income is, if we have that, how many purchases they've made in the store, how many times they visited the store. Now, not all of this information comes from our CRM. Some of it comes from our web analytics traffic. There's a lot of different sources, and thus, as someone very wisely mentioned a little while ago, 55% of the effort is actually getting this data into a format that we can train the models. And so when we scroll down through this notebook, we build a number of different things, and then we talk, and then within the notebook, we say, okay, user, what metrics do you want to, what dimensions do you want to focus on? Whether they've made a complaint, what their age is, and gender. One of the great things about data science and doing all of this work in Databricks is that you can kind of iterate over these examples right within the notebook. So your data scientists can do all of their work within inside of Databricks to provide a different number of different items. So we're going to select all of the items for clustering. And for that, we're going to generate a number of clusters around all of this information. And so when we generate a correlation metric, right, where we correlate the dimensions to each other, what we're looking for is a number of different items where the correlation is low, right? What we want to look for is something where we can segment the audience. And so the correlation being low is a kind of a good thing here, closer to 0 than it is closer to 1 or -1. And we find a number of different things. So when we're grouping our customers together, for example, income and kids at home provide some really clear distinctions within our data set. as so does how many visits a month plus income, or number of visits. It's the same thing right here. So once we've identified kind of what dimensions we want to cluster on, we go through this process again, and then we create our clusters. And at the end of this cluster, we have kind of a distribution of what those different metrics are. And this can be really useful to kind of fine tune. The closer the things are correlated to each other, the closer the distributions are going to be when you compare those two groups. And what we essentially want to find is we want to find where are most of our customers sit over a number of different dimensions. And that's what we're going to tell our computer to kind of look at when it's building the clustering. So after we determine what our clustering has done, we're going to do what's called an elbow analysis. And as you can see, we did a lot of research getting to this demo. And so when we do this segmentation, we're going to choose the metrics that we want to add to our cluster to kind of identify where they are. And then different items which had the highest distribution or the greatest chance of creating a unique data set: education, income, kids at home. And with that, we produce what's called an elbow chart, right? Using the elbow method, which is a data science term, we find the amount of clusters that gives us the highest grouping possible. And for this, we chose 2, which is why you saw cluster 0 and 1 on the initial chart. And we go through all of this, and we go through all of this, we go through all of this, until we get to kind of what our most profitable sector is, which is our cluster 1. And we can drill down further into the dimensions that we want to look at, right? So for example, the education distribution in our top most profitable cluster is graduates, and they're usually married, and they usually have 0 kids at home, which makes sense because arguably that would be the most disposable income available within a house. And then, however, of those groups, if they have a teen, so not a child, but a teenager, that's a larger group here as well. And then most of them have only made, up to 3 purchases. That covers about 70% of our demographics. So this gives us an idea of who to target, what psychographic elements that we can chart. So when we do our future forecasting and future reach out, we can target people with these criteria to bring them in because we know that they are the most profitable customers coming in. And so there we go. That is all of our gender. Surprisingly, within this data set, and this is often part of the iteration process, there's not a clear distinction in between gender in the data set. Now, some of that might result in a data cleaning being required, and some of that might just be an idiosyncrasy of the data. So now that we've identified what our most common customers look like, we want to know, how do we kind of tell them what to go buy after they've added something to their cart? And for that, we're going to use another data science application. In this case, it's called a recommendation engine. So again, we're going to import the labeling that we've already done, group the customers into the groups that we already have. And so then what we're going to do is that we're going to do a little bit of personalized recommendation. So when a new customer comes into our shop, and we know as much information as we can, we're going to make personalized recommendation on people that look like that user, either by age or gender or education level, whatever that ends up being. But then what we're also going to do is we're going to take the most profitable cluster of items that we've sold to that most profitable cluster, and we're going to create a recommendation based off of that. What this allows us to do is to say that most of the people who buy this one item buy multiple items, and thus result in the highest revenue for us. And so we want to make sure that in our recommendations to the users that we also include those items as well. And then finally, we're going to put our thumb on the scale, which is another thing that a lot of people don't talk about data science, is that you can add a little pressure to it. And the items that are the highest generating income, these are just the ones that have the highest profit margin, or the ones that are on sale, or the ones that need to get out of the warehouse because they're being discontinued. We're going to make that application as well. So when we create those 3 different recommendations, what we eventually get down to is a number of items that we would recommend by user. And so when this person makes a purchase, we look at their psychographic groups, we look at the most profitable group, and we look at the ones where we've kind of added an item and do all of that. You can see, for example, here the top subcluster items and the top revenue items. And then finally, we make a recommendation with just that subset. And we can produce a dashboard that we can service to our customer service representatives. So for example, when customer with ID of 12405 come in, we're going to make 5 recommendations to them, either based off of their psychographic information, the information that we want to get rid of, or the most profitable items. And we're going to let them know that they should go buy a set of 4 picnic cutlery in blueberry color. However, when their neighbor calls in, we're going to make different recommendations to them because they have different psychographic information. They have different values based on what they've bought in the past, et cetera, et cetera. And we're going to recommend to them that they buy the chili lights because everybody likes a hot summer, right? And so for all of this, right, this is all data science up to this point. 55% of data prep, 35% of model training, and about 10% of implementation to surface this recommendation form to our customer service reps. Now, that's all fine and good, but Bryan spent a lot of time talking about preparing your data for generative AI, and so I feel a little silly not doing that. So let's talk a little bit about what we can now use as recommendations to build out personalized content generation. So we've taken a user and we've made 4 recommendations to them. And we're going to create 3 new original pieces of content to target either this demographic or this particular user. So the first thing that we're going to do is we're going to give our customer service rep a reason when they're on the phone or when they're chatting with a user, why they should buy this item that's recommended for them. The second one is we're going to create a customized email with those recommendations and links to those products to each individual user so that our customer service reps have something to do at the end of the call. And then because we don't want to leave out our marketing team, we're going to help them by creating for this psychographic group a custom Instagram story script so that they can quickly go and generate that content and put it out. And so when we do all of this, and you'll excuse me for not rerunning this in a live demo, the first one is very simple, and this can be fed to any CRM or anything programmatically. Essentially, what the name of the object is, what the description is, right? So for the white hanging heart tea lights, create a cozy ambiance with the elegant white mapping heart tea light holder, perfect for any romantic or serene setting. So for a user that is married, this might be a good thing. For a single person, you might want to add something else, which is why it's important to pull as much information into the system as possible. The second one is our email, right? Creating a narrative around this story so they don't think it's immediately spam. Imagine unwinding after a long day with the calming scent of your hyacinth bulb, illuminating the space with elegance, lazy afternoons with your hammock, or escaping with a good book and transforming your bathroom into a sanctuary with the floral bathroom set. Obviously, what we recommend is that a human being actually touches this before going out, because that might be a little too heavy-handed, depending on what your prompt feeds into. And then finally, for our marketing reps, here's an Instagram story based off of one of those items, right? What the background looks like, what the text overlay looks like on the screens, everything like that, so that they can quickly go and turn around a custom model very quickly. And so if we shift back to our demo, to our deck, we can say that, you know, there are a number of generative AI applications that our users are actually coming up with, right? So in this example, based on previous purchases, we've created a whole bunch of items. One, a better recommendation for those users, as well as custom content that's designed to get them to buy more stuff, which is the overall goal of a customer of a e-commerce store, right? Reducing the cost of creating an email with information about what the user has purchased or what we would like them to purchase. Again, saving some of that 2.5 hours that our knowledge workers are doing. And then iterating the information, doing A/B testing from those emails, from those Instagram posts to reinforce our model and provide new ways for us to cluster our data and allowing you to even get further more information about your users. And then finally, if you feel that it's up to it, and there's a lot of risks here, but creating kind of a personal shopper bot that helps send users to the right places within your website based off the information that you have on them. This all really helps you build out from raw data through generative AI. At each different step, data science and the generative AI helped you increase your users' experience, increase the potential revenue from each one of your customers, and grow your business. So with that, we are going to go to some questions and answers. Bryan, one of the questions that came up, and I'd love to hear your feedback on this, was, when you're starting out all of this, how do you kind of select a generative AI project to even work on? How do you choose out of all the possibilities? How do you choose one over the other?
Yeah, I mean, excellent question. So thank you. Really, you need to think about the desired output of the project, right? If you're if you're considering, if the result is, I want to make a forecast based on a few different points of metrics or something like that, generative AI probably isn't the right solution for that. If you want to generate a multi-layer, suggestion or content around something that's very specific to, the way a user may be thinking, may be feeling, their experience today, things like that. That's where generative AI comes into play. And ultimately, if you think about where your internal folks or your customers are spending a lot of time doing research, or prepping for something, or that is where generative AI really is a strong fit.
And I think one of the other things to add on from just putting on my solution engineer hat, one of the other things is, do you have the data to help feed into the generative AI model, right? And so when you're looking at these generative AI projects, a lot of this work is going to come in the data engineering aspect. And so what you should do and what you should think about is, where can I get a quick win? Because most of these generative AI projects are going to scale and they're going to be iterative in their deployment. And so the quicker that you can get to some value, right, the better. And so when you're talking about what generative AI project should I do, my question to you was really much more of, well, what are you spending the most time on, or where do you see the opportunity to grow the largest? And then to Bryan's point, backtrack that into the matrix that we showed earlier. Is generative AI the right answer to that problem, or is another data science method probably a better fit for where you are as an organization from a data maturity standpoint and what you're trying to get out of it in the biggest possible way? So another thing is kind of along those lines, right? Is that, Bryan, one of the other questions that came up are, what are some future trends that we're seeing as data practitioners in kind of the data science and AI worlds? Like, 6 months from now, what are we going to be talking about? Are we still going to be talking about data science and generative AI, or are we going to be talking about some other different application?
Yeah, so looking into my crystal ball, right, and just seeing where where the world is taking us these days. You know, generative AI, isn't going to, it isn't going to automatically run anybody's business, right? It's not going to automatically predict, well, maybe not in the next, 6 months. Someday maybe it'll get there, but ultimately the conversations that we're going to be having are how the businesses that are going to be most successful in leveraging AI are the ones that are going to apply, as I said, earlier, their unique perspective, meaning their data, against sort of the foundational models and the general, all foundational models are generally trained on data that anybody can find in the world. Whereas augmenting that with your own unique perspective is going to give you the ability to generate a style unique to your business, or consider it now, right? The Gen AI, you can say, write me a song in the style of Bob Dylan or something like that, right? So you can do the same thing, right? Make a a shopping cart based on the style of this particular user. So the companies that are leveraging those kinds of things are the ones that are going to get the most benefit, the fastest return, and ultimately grow their business the most.
One interesting thing I actually heard this morning was there's a new podcast called Shell Game, and essentially the author, podcast lead, or whatever had created an AI clone of himself. He had cloned his voice using one of the many tools out there, had set up a voice activated chat bot, and done a little bit of RAG data engineering on the back end. And he had it call families and friends and telemarketers and all this sort of thing without letting them know that they were talking to an artificial intelligence bot. And he said that the most interesting thing that he was looking for was the reactions. And so most human beings that knew him a little, or were even interacting with him for the first time, realized that something was amiss, 4 to 5 minutes into the conversation. And then outside of that 5 minutes, one of his friends stood on apparently and just thought that he was having a nervous breakdown and that he needed some help, right? And so when we're talking about these AI agents, kind of going into the future and building all these things and doing these things and not autonomously, what we have to know is that first off, the data coming into it is super critical, and the models are simply not there right now to generate a realistic human experience. And so that includes decision making, that includes tone of voice and language problems and all sorts of things. And so when you're looking ahead, I still think that data science and generative AI is best used with a person judging its result before it's used in a business decision. I don't see that changing in the next 6 to 9 months. I have a hard time seeing it in the next year and a half to 2 years. But that's something also to keep in mind, is that these systems are good for predicting things. They're not particularly good for creating original content, because even when they do create original content, they're essentially just predicting what the next word in the sentence is. So just keep that in mind. I think we have time for one more question. And so I think let's ask this because it's close to my heart. What role does data quality play in the success of generative AI models? And so, Bryan, I'm going to talk for a minute and then you can add on when I'm right. So essentially, data quality, we talked a lot about this throughout the entire webinar. Garbage in really does result in garbage out. And when you're dealing with predictive models in data science, or recommendation engines in data science, or even generative AI, the garbage out may not always look like garbage, which is even a harder thing to kind of diagnose, right? If the generative AI model says the sun is red, well, the answer to that is, well, of course I know that's wrong. But if you say that the sun has hex code of pound 000456 or whatever, maybe that's right, maybe that's wrong. We don't really know, right? And so what we really need to talk about when we're talking about data quality is A, making sure that the data is governed and is quality checked before it gets to the model. And then the results of the models, whether it be recommendation engines, whether it be generative AI models, that a person, a living and breathing human being, actually looks at the results periodically to make sure that the answers make a lot of sense. And so when we talk, for example, and when I generated those custom emails, the paragraph that it generated was factually accurate, but it had a tone issue. Some of that you can solve with prompt engineering, but some of that just requires a human being to start the email and augment the email with their own capabilities, with their own understanding. But if I didn't even have the data quality coming in, knowing that that was confident, the recommendation engines would be off and I wouldn't see as much of a return. And then the generative AI outputs would have also had their own problems as well.
Yeah, I mean, spot on, right? The way to prevent things like hallucinations and things like that in the content that gets generated by an LLM or even on smaller scale is making sure that the data that's being used to train um, is representative of the outputs that you'd hope to get, right? Or representative of realistic data that's coming in. Right, if you only train on super clean lab data, right, or fake data, and then real world data comes in and it looks different, your results are going to be different, right? They're not going to be viable in my opinion. So you definitely, to Andrew's point, you definitely need to spend a lot of time, that 55% of your time, making sure that the data that goes into your training is high quality, as well as formatted in a way that will look like real data coming in.
And the great thing about using Databricks to do that is that you can do a lot of those sanity checks in a number of different places through pipelines or through notebooks within Databricks and constantly refine those data quality rules and all of that as well.
Excellent point. Probably one I should have mentioned.
Well, that takes us to the end of our audience Q&A. If you had a follow-up question that we weren't able to get to, please shoot us a note, either through LumenData's LinkedIn page. Also, we'll be sending an email out with other contact information if you want to discuss this further. My marketing team will be mad at me if I don't suggest our next two webinars coming up. The first one is driving innovations in life sciences with trusted data. That is in 2 weeks, the 26th, so a week, I guess. That will be, again, you can register today on the LumenData LinkedIn page. And then also, my face will be back in your feeds in early October when we're talking about generative AI in some of our private equity portco companies. We'll be doing some more live demos. For example, we've also built a chatbot, a generative AI application that takes in current web data along with data from a user to produce a number of quotes for insurance companies. We'll be talking about that and some other use cases on October 10th, which is a Thursday, the second Thursday in October. Again, that registration will open soon, but keep apprised of our emails for that information. And then finally, I think just thank you for spending an hour with us as Bryan and I talk about AI and data science. We really appreciate it. If you have any questions, please reach out to either one of our emails, which are there along the bottom, but will also be distributed in a follow-up email from LumenData. And with that, we're going to say goodbye and let you get back to the rest of your Thursday afternoon. Thank you so much.
Absolutely. Thank you all.